Hello, this is Cliff Jordan. I want to showcase to you a program that I just finished. I wrote it a couple weeks ago. I finally got it up and loaded on the internet so anybody can go to it. You can find a link of it down below. You can go to that link and you can run this program. And I want you to run this program. And the whole purpose of this program is to help people understand that climate change is a real thing. This is not a joke. It's not a conspiracy. It's real. And you can prove it to yourself if you run this program. What this program does is it pulls data from one of 2,400 weather stations from around the world. You get to choose whichever one you want. And it will pull all the weather data for that weather station, or all the temperature data, going back as far as it can. Now, there are a whole lot more. There's actually like 24,000 known weather stations to the NOAA, which is the National Oceanic and Atmospheric Administration. There's over 24,000 that are up and running, but the problem is a lot of them, most of them are fairly new in the last 10, 15, 20 years, and they don't have enough data to show the trends that we really want to show. So what I did is I went out there and I kind of scrolled through all of them and found those that have data since 1980. It's about 2,400 of them. And some of them have data that goes back to the 1920s, 1930s. So depending on which one you're going to get data anywhere from 1920s, 1930s to starting then or starting in 1980. Okay. This all came out of a discussion that one of my childhood friends, Ray Dyer, and I had for several years about the validity of climate change. He challenged me to put together a program that would show him how climate change is impacting at least 10 cities. Okay, so Ray, I'm done. But it's not 10 cities, it's 2,400 and change. So I've overdone what you asked. But the cool thing is, seriously, you can choose any one you want. Now, I've pulled data using this program and trended out for, I'd say, 20 or 30 different places around the earth, specifically looking for places where it actually dropped. I have not yet found a place that has dropped in temperature. It doesn't mean it doesn't exist. I just haven't found it yet. And maybe you can help me if you pull data from it. But everyone that I've checked is either increasing or maintaining stability. So in other words, the temperature for the last 70 years has been pretty much stable, or it's increasing. Okay. Now there's different reasons why temperature increases and why the Earth is warming up and we have climate change and all that. And by the way, climate change is better than global warming, because what happens is as the Earth increases in energy because of the temperature, it's going to cause more dynamicism, if that's a word, but the weather's going to be a lot more dynamic because of the increased energy, which means you're going to have stronger storms, you're going to have stronger wind currents, stronger oceanic currents, which means you're going to end up with greater variances in temperature. And so as you have likely increased temperatures in most parts of the earth, you will likely have some places that actually have decreased temperatures in the earth. I don't know where they are yet. Haven't found them yet. Everything's showing that it's increasing, but I'm sure there's some places out there that is decreasing in temperature. But anyways, to run this program, this is what you got to do. You got to go over here. I'm going to go to the link. You click on it. It comes to here. You click on this little run right here. And what this does is it allows you to choose whatever weather station you want, and it chooses by location. So you've got different places. You should go to Greenland, for crying out loud. It's cold up there. Check that out. Spain, it's got some good stuff there. Morocco, interesting stuff. Iceland, hey man, you got to check out Iceland. Let's go to the United States. It's got the most weather data. Choose any state you want out of all 50 states. Just for fun, let's go to Alaska. Yeah. What do we got in Alaska? Oh, look at all this good stuff from Alaska. Gnome. I've never heard of that. Let's check that. Gnome. See, I don't even know what the weather's going to look like here. So you click this weather station in Gnome, wherever Gnome is. I have no idea where Gnome is. But you click it, and then you say run. And now what we're going to do is we're going to wait, and it's probably going to take about 3 to 5 minutes. What the program is doing is it's going out to the NOAA, the National Oceanic and Atmospheric Administration. It's pulling all the weather data from Gnome, and then it's going to start analyzing it and trending it for every Julian day of the year. Now you're saying, well, Cliff, what is a Julian day? Well, a Julian day is the number of the day in the year. So January 1st is the first day of the year. That's Julian day number 1. Let's see, there's 31 days in January, so Julian day 32 would actually be February 1st. Okay, so what this does is it will take, for every Julian day, it creates an analysis of that Julian day starting back from the earliest year all the way to the most current year. So let's imagine that, what's today? June 22nd, 2020. So we're going to choose June 22nd. If I started off looking at 1948, for example, and chose June 22nd for 1948, June 22nd for 1949, and 1950 and whatnot, and let's see how it changes. The temperature changes for June 22nd as time goes on. That's what is being trended here. Okay, and for the trending, we're actually looking at the minimum temperature of the day. So you got 2 temperatures that are important. Typically, you get your minimum temperature, which is the minimum temperature, which typically happens right before sunrise. And then you've got your maximum temperature, which is typically in the middle of the day when you have the sun at its greatest point in the sky. Now, I chose the minimum temperature to actually trend that. And the reason for that is a valid reason. It's because it's the most stable of the 2 temperatures, the maximum temperature and the minimum. And the reason for that is because it's more stable because there's not been as much energy input to the geography over the night because it's nighttime. So we don't have all that solar energy. And so there's less dynamism. Is that the word? It's less dynamic. And so it's a little bit more stable. And if you look at the graphs you'll see that indeed minimum temperature compared to maximum temperature is a more stable temperature. So that's what we're using to do our trending on. Anyways, I'm going to go ahead and pause this and let it do all its number crunching, and then we will analyze the output. I'll be right back. All right, we're back. It finished. So let's go see what we got. There's 3 files. Only 2 of them will you really be interested in. The first one is the raw data. This isn't a spreadsheet. If you know Excel, you know how to program Excel, you may want to see the raw data yourself, and you can download it right here. So I didn't want anyone to say, I wanted to supply the raw data so that anyone, if they wanted to validate my analysis on the trend lines, go for it. You can do it. It's right there. The raw data. Download it. The PDF, that's the one that's the most important. This has all the analysis. To download the PDF, all you do is click on it here, go over here, select the format as PDF, hit download. And what it's going to do, it's going to go ahead and allow you to download it. I'm just going to put here GNOME, just rename it and hit save. And voila, I'm downloading the GNOME. Now let's take a look at what's going on in GNOME. I still have no clue. Where's GNOME? I have no idea. Let's see. It's Nome County. Okay, so it's a county in Alaska. So this is the temperature trend line for Nome, WSO Airport, found in Nome County, Alaska. Oh, it goes all the way back to 1940. Check that out. January 1st, 1940, all the way to 2020. Okay. Here's the summary page. Now, what the summary page does is it shows you for the last 70 years the slopes. So if you just looked at the slope of temperature increase from the last 70 years, it's increasing 0.06 degrees per year, which is 6/100ths of a degree every year. If you just look at the last 60 years, in other words, starting 60 years ago, going today, and did a trend on that, it's a little bit different, but you're increasing 8/100ths of a degree every year, and so on. But you notice that as the closer you get to the current date, the slope is increasing, which means that, sorry to say, temperature rate is increasing. Okay, and wow, the last 10 years it's 0.84 degrees. That's almost 1 degree per year. Now I have no idea where Nome is. In fact, just for fun, let's just go check. Nome, Alaska. Nome, Alaska. What is even there? Oh, we got a church. A lot of snow. Oh, check that out. There you go. There's Nome. Cool. Not a big city. That's interesting. This is really a cool. I'm glad we chose Nome because Las Vegas is increasing a lot. So is Phoenix. If you look at Phoenix, it's increasing in temperature every year a lot. The slope is significant. But you can explain that for several different reasons. One is why is it increasing in Las Vegas and Phoenix? Well, both of those places are growing exponentially. I shouldn't say exponentially, but they're growing in size significantly in the last 50 years. And with the added population that's coming in, you got more cars, which is generating more greenhouse gases like carbon dioxide, and that is going to trap the air or trap the infrared light from radiating out at nighttime. And so it's going to trap the heat in. So that's one. And then you get more asphalt because the city's growing. And so that's going to hold the heat in. And not just the asphalt, but all the cement and all that holds the heat in. And the other thing is that, especially for Las Vegas and Phoenix, it gets so dang hot in the summertime that we have all this air conditioning that's going on. And so you get pumping all this energy to run all this air conditioning. And that is cooling the inside of the houses, but it's making the outside of the houses even hotter. So that's increasing the heat as well. So those three factors, you can explain the heat, why the temperature in Phoenix and Las Vegas is going up. But look at Nome. Look at that. It's a small little town. I wonder how many people live there. And in a little town like that, you don't have a lot of asphalt. You don't have a lot of CO2 gases. But it's still increasing in temperature. Interesting. Well, anyways, let's go back to our report. Well, let's see. That's up there. Here it is. Yeah, so we're seeing that it's increasing 0.84 degrees every year since the last 10 years. I put in some notes here that kind of tells you how the math that I use to calculate all this. So please read that. These are my kind of give you the understanding of how it's all done. And then I show you some graphs. Now what I did is I chose 4 Julian days out of the year at random. There's one from each quarter. So the first quarter is January, February, March. Second quarter is April, May, June. Third quarter is July, August, September. Fourth quarter is October, November, December. And one day in each quarter was chosen at random. And then I went ahead and I trended out in graph form the temperature. So let's look at this one. Here's actual raw data for March 13th. Wow, this is cool. Look at this. This is exactly what I expect from Nome. This is what I expect. Look at the temperature. You get a lot of variance in temperature, the min temperature from Nome. But look at this. This is the trend line for the last 70 years. I think it's this one right here. It's pretty much flat. In fact, if you look at it here, it's for 70 years, it's 0.017. The slope is like flat. Not much of a degree change, for that particular Julian day. Okay. So look at this. This is cool. You see that it's flat for that one for the 60 year. Well, you notice here how the temperature kind of went up and then went down, and then it went up, went down, went up, and it's kind of all over the place. But if you look at the 60 year, it's where it started down here and kind of goes up. You see it increase at 0.20 degrees per year. If you look at the 50 year, it starts right here. It goes up 0.13 and so on. The interesting thing is what's going on here. This is 20 years ago. The slope is actually decreasing. Interesting for Nome. For this particular day, just one day of the year, not the whole year, one day, it's actually decreasing. That day trended across, since 1940. If you look at the last 10 years, it's increasing 1.3 degrees. So the reason this is significant is that climate is not weather. Weather is very variant. Climate requires averaging of data, of temperatures and stuff. And the more temperatures you average over a certain period of time, the closer you're going to get to the real amount of climate change. And so if we're only looking 10 years back, or even 20 years back, it's kind of variant. It goes up and down. I mean, if you start going back 30, 40 years, you're going to start to see more of an accurate trend. This is, like I said, this is just for March 13th. Let's look at another one. Oh, look at this. It's June 10th. Okay. So it's also pretty flat. I see it went up really high during the 1950s, and then it kind of went down. But you kind of see here the trend since, let's look at the 1970s forward. You see this trend going up. It went down, and then it's been going up steadily for Nome, this little podunk city out in the middle of Alaska. So for the last 30 years, wow, it's going up 0.26 degrees per year. Okay. Let's look at another random date. August 1st. August 1st in the middle of summer. Okay, so in the middle of summer, it still gets down in the 30s and the lows, and it gets all the way up. Ooh, a few years ago, it got up to a blazing 60 degrees. Holy cow, they must have been like suntanning out there. Nome, Alaska at 60 degrees in the summertime. Anyways, they've got, you can kind of see they're increasing across almost all of the different slopes, and they all increase. Okay. October 30th, near Halloween, you can kind of see it's been increasing, except for the last 20, 30 years. 20, 30 years it actually was negative. You kind of see that right here. 20, 30 was negative. Okay. So, just because you see some negatives for one particular day, don't take that out of context. What you need to do is you need to look at all the days and then average it all together. And that's what this program does. So it takes every single Julian day, and that's what this table is down below. It shows you the slopes for this one down here, every single Julian day for the last 70 years. Okay. So this is the slopes for Julian day 1, which is January 1st, and it takes every single Julian day of the year, okay? And it figures out those slopes. Now, if for those slopes, if you average all of those, for the 10-year slopes, if you average all those together for all Julian days, then you get the overall average, which is right here. So this is kind of the average of all days, across 70 years. So that's how these numbers get calculated. So you can actually do that yourself and figure out how it is. Okay. There you go. That's Nome, Alaska. That was just a fun little experiment. Try your city. Try your favorite city. Go find out. Are they experiencing an increase in temperature? Are the slopes increasing? Are they positive? Or are they negative? Like I said, it's very possible that we could find that there are some places in the earth that are actually cooling. I haven't found them yet. Help me find it. But you got 2,400 different places around the world you can check. Okay? So let me know. Go down there. Pull some data and let me know what your results were. It'd be fun to see what everyone's results are. Anyways, and like I says, I give you the raw data, so if you don't trust me, you can do it yourself. You can look at the raw data and calculate your own averages and validate all my math. Okay, that's what good scientists do. They give you the data, they tell you how they calculate it, and they let you validate it. which gets back to this whole thing. Thinking that global warming or climate change is a big conspiracy, it's not. It's not. You do not have thousands upon thousands of scientists out there fabricating data just for some political purpose. You don't get that much support. If you're a politician, you say, I want to promote climate change because I want whatever, you're not going to have, you're going to find it extremely difficult to convince thousands upon thousands of scientists to go out there and muck with the data to prove it. It ain't going to happen. And in fact, you're probably going to get the exact opposite. You're going to have thousands of scientists coming out and saying you're wrong, and the data has proven it otherwise, etc. So, bottom line is, it's not a conspiracy. Please, don't think it is. There's a lot of things out there that are being promoted as conspiracy theories that are not. The stuff is real. I wanted to prove this, and I've done it. You can go out there and check it for yourself. Do it. Have fun. Go look at your favorite city. See what's happening. Anyways, there you go. Have fun with this, and I challenge you to look at least 2 or 3 cities. Thanks.